Good morning, good afternoon, and good evening, depending on where you're joining us from. Thank you so much for taking some time out of your day to attend our webinar on Percona Server for MongoDB migration. My name is Kim Everhart, and I'm a member of the marketing team here at Percona. And I'm going to go through a few housekeeping items before I turn the presentation over to Barrett and Stephen, two of the engineers here at Percona, who are going to walk through this webinar for you. So first and foremost, everybody is muted, but we welcome questions. So there is a question and answer box. Feel free during the presentation to drop any questions you have in there. We will save them for the end and go over them as time permits. If we run out of time, we will still get those questions answered, and we'll do a follow-up blog with the recording, as well as any questions that came in that we weren't able to address during the live presentation. I'm going to do a visual check now. Can everyone see the screen? And it shows, should be our intro slide. If you can you raise that little hand icon on your interface, just so I can make sure all is good. So I see some hands going up. So I think that's a good sign that our visuals are set. Also, I'm going to assume you all can hear me since you responded, but let's check and make sure you can hear our speakers today. So Barrett, could you just say a few words and we can check your sound?
Yep, sure. Hi, everyone.
Okay, if you can hear Barrett, can you please raise up your hand icon just so we can make sure we're all good? Awesome. And then Stephen, can you do the same and just say a few words?
Sure. Hello, everyone.
All right, if you can hear Stephen, all right, I see the hands going up. This is great. I think we're all good then. So one last thing before I turn it over to Stephen and Barrett to get this started is we are recording this. So everyone that registered will get a copy of the recording within 24 hours via email. So just keep your eyes open for that. And in the meantime, sit back and enjoy. All right, Barrett and Stephen, I'm going to let you guys take over.
Sure. Thanks, Kim. So hello again. This is Stephen. I'd like to thank you for coming today. I'm a solution engineer for Percona, and I'm joined with my teammate, Barrett.
Yep. Hi, everyone. I'm Barrett Chambers. I've been a solutions engineer at Percona for a little over 4 years now. Excited to be talking about this topic. It's a popular one for our customers and potential customers, so hopefully you guys get some value from it.
So our webinar today is focused on migrating from Mongo Community Edition to Percona Server from MongoDB. We're going to start off by talking about what Percona Server for MongoDB is and some of the features. We're going to talk about the two most common migration methods, and then we're actually going to show you or demonstrate migrating off Mongo Community Edition to Percona Server for MongoDB for both those methods. Like Kim said, send us questions during the webinar. We'll answer those at the end, and we will also follow up with a blog post answering the same questions and anything that we could not get to.
Great. So whenever we're talking about MongoDB, I like to kind of point out the philosophical debate between MongoDB Inc. and Percona. So MongoDB is very good at producing enterprise-grade proprietary software that enables developers. And their strategy as a business is to have more adoption of those proprietary enterprise features. And here's a quote from the CEO of MongoDB highlighting that. And on the Percona side, we're a little different. We advocate for truly open source solutions, and MongoDB community is open source available under the new SSPL license. And it is the foundation, as we'll explain in later slides, of Percona Server for MongoDB. So on the Percona side, we provide the fully open source solution, and our CEO has been quoted saying that, and we've been doing that for 13 years now, continuing in Postgres space as well now.
So we're going to talk about how we actually build Percona Server from MongoDB first. So like Barrett alluded to, we actually build on top of Community Edition. It's the exact same code base. And this is great because it makes it a drop-in replacement. It's 100% compatible with all the community features. And then if your application is using Community Edition, you can put Percona Server in there, and it's going to work. We then start on by adding critical bug fixes. So we have our own in-house support, bug prioritization, and engineering teams that'll add bug fixes that our customers submit, but also the community at large. So by using Percona Server, you're kind of benefiting from the community and all of their collective efforts in terms of bug reporting, and then our engineering team's efforts as well. We then tack on some scalability enhancements. So these would be things like profile rate limiting or our Percona in-memory engine. We'll then add on enterprise features. I'll go over these in a couple more slides, but things like audit logging, log redaction, and data at rest encryption. And then add in community features. This would be something like a WireTiger hot backup. We then take that and we put it through a rigorous enterprise level QA process. We package all that together, and then we release it back to the community as 100% open source and free. And I'd just like to reiterate that first building block, Community Edition, because again, we're using that same code base. It is a drop-in replacement. Some of the features you get from Percona is you get all the enterprise features. You're not paying Mongo Inc. Licensing. You're not locked into using them as a vendor. We have all of our enhancements for it, so it's better quality and more performant. We do take features from the community, like our in-memory engine. So if you have a contribution, we actually will look at that and incorporate that into our software if it makes sense. And because we add all these features, it's enterprise ready. So I know we're talking about Percona Server for MongoDB today, but I also want to mention we have a backup tool as well and a Kubernetes operator.
Yeah, and the Kubernetes operator is a focus for us currently. We have an initiative to provide our customers with a cloud native deployment methodology. And that's kind of like buzzwordy, but really our goal is to give our customers a deployment method for their database technologies that doesn't really care whether you're on-prem, hybrid, Azure, Google, AWS. You'll still be using the same deployment methodologies, management driven through Kubernetes-based APIs. So it's really easy to manage. So that's a huge focus for us right now, but that's a probably separate webinar. We're going to focus on just getting to Percona Server for MongoDB.
And I mentioned some of the enterprise features that we have. So these are the most common used enterprise features with Mongo Enterprise and Percona Server. So with these features, we do have feature parity. Again, we're on Community Edition, so all the community features that are in Mongo community are in Percona Server as well. We also have LDAP authentication, LDAP authorization, and Kerberos. So those are the external authentication and authorization mechanisms that you would use to verify your client's permissions to that Mongo database. We have auditing, so you can track and log your user activity on the Percona Server for MongoDB server. And that audit log is going to contain information about the different user events, however you actually define them. We have log redaction. This is going to allow you to prevent writing that sensitive data to your diagnostic log. And it does this by redacting those messages of events before they're logged. We have a hot backup. So this creates a physical data backup on the running server without a noticeable performance hit. We also have point-in-time recovery backups. So you can recover your entire replica set or sharded cluster to a specific timestamp. We have data at rest encryption. So this is encrypting the actual database files. So if someone was to get into your system and somehow obtain those files, they would not be readable without that actual encryption key. We have an in-memory engine. So all your data is stored in RAM, making it a lot more faster and performant. And like Barrett had mentioned, we do have a Kubernetes operator as well. So if you are using Kubernetes and are interested in looking at Mongo, This is going to help you automate a lot of those operational functions like backups, self-recovery, upgrades, and a couple other things.
Great. Yeah. So, I mean, you can tell from this slide that a lot of our engineering efforts are spent around security compliance functionality that MongoDB makes enterprise and charges a license fee for. And that just gets back to sort of their freemium strategy. It's like you can start out with Mongo, but once it starts getting mission critical, or you're storing PII data, SOX compliance, that sort of stuff, you're gonna need to either choose enterprise or Percona Server for MongoDB for those deployments. I do have one question for you, Stephen, on this slide. So we are Percona, we try to remain unbiased, but is there anything missing on this slide that maybe enterprise has that Percona Server is missing?
Yeah, there are a couple things. We'll get questions about some, things that aren't used as common, what we consider like edge cases that we just don't have. So there are a couple things that Mongo Enterprise can do that Percona cannot. One example would be, maybe a specific build for just a kind of obscure operating system. That would be what we would consider an edge case, and that we wouldn't have.
Yep, that makes sense.
And I know you alluded to looking at Mongo Enterprise or Percona Server. This is just a pretty basic graph comparing the two. So you have Mongo Community. You don't get those enterprise features, but you are not locked into using Mongo as a vendor. If you wanted to go with Mongo Enterprise, you would get all the features, but you're also locked into paying MongoDB, whatever they want to charge you. And then you can also look at Percona Server, which is kind of the best of both worlds. So you have freedom of choice. You can choose us as a vendor or not. And you also get the enterprise features. And the reason we're kind of focusing on these two, they're kind of the big players in the Mongo space in terms of server options, and there's not really any other comparable options unless you're going to look at using a different database technology, which could be time consuming if you're looking at re-architecting.
Yeah, and I would say one, I guess, alternative that we hear pretty frequently is Amazon's DynamoDB, which is a database as a service on their platform, which is a fork of an older version of MongoDB that's based on an AGPL version of MongoDB, which doesn't have the SSPL language. So licensing is a whole other conversation, but basically with the SSPL, MongoDB is trying to stop cloud vendors like Amazon from taking their product and turning it into a database as a service offering.
So now that we've talked about what Percona Server for MongoDB is, everyone's here obviously to learn how to do the upgrade. So we're going to talk about that.
Yeah, and the two most common methods that we see are in-place upgrades. The benefits of doing an in-place upgrade is that, first of all, it's pretty easy. It's very quick. You don't require provisioning new VMs or hardware. So if you have to, deal with an infrastructure team to do that, you cut that out completely. There's no process for submitting tickets to get all access to all that stuff. One negative of an in-place upgrade is that it does require downtime on that node. So if you're, in a one node deployment, your application's not going to be able to service requests during that. So you need to keep that in mind. Method two is a replica set takeover. So this is more common when you want to have as close to a zero downtime upgrade as possible, or when you're using proprietary features on the MongoDB enterprise side. So if you're using encryption at rest, you're going to have to do a replica set takeover where you're allowing full data to sync, because you can't just kind of drop in with that encrypted data. We have different methods for doing that. So you'll have to let Percona Server encrypt that data from zero, which can take a bit of time depending upon how large that replica set is and how many transactions are running. But the benefits are that from an application perspective, you're servicing requests that entire time, except for one moment where you're stepping down. So those are the two primary methods that we see, and the two that we're going to be demonstrating today.
Just a little background about the demonstration. So this webinar actually was built off a hands-on workshop we had built internally at Percona for customers and prospective customers as well. So this would include each actual attendee would get their own lab environment with a set of servers, and they would actually have a lab guide and go through and be hands-on performing these exercises. But we actually needed to adapt that to the webinar format. So what we did is we recorded videos of all the steps. So you're still getting the same content, but it's actually probably presented a little more streamlined, and we can focus on what actually is going on too. So I feel like it's a better presentation of the material. So the two exercises are the two upgrade methods, the in place, which we'll do first, and then we'll move on to the replica set takeover. And during this, we do use a couple scripts. I'll explain what they're doing during the webinar, but if you're interested in the actual steps, we have a guide online for upgrading as well, or you can reach out to Barrett or myself after, and we can kind of point you in the right direction to get you the information. And we're going to start off with the in-place upgrade method first.
Yep, so in place for this one, we're gonna be super simple. This is a single server running MongoDB community or enterprise. The application is servicing requests from this database. So the larger database is just representing the server, and then the smaller little database icon down there is your data. So during this step, we're going to be running a query script, which is basically just showing, hey, we can access the data. So it's mimicking like your application accessing data, and then showing, what's in the database.
So for this video, we're just going into our scripts folder to run this initial query script. So it's called db query. That's going to return a total document count, which is 29,353. We're basically just showing that there is a server there with data, and it's up and running.
Yep. So now that we've shown we have a server running, we have to do the in place method, which involves a little bit of downtime. So that downtime is experienced when we stop the Mongo process. It's no longer going to be servicing requests to that application. So you would want to do this during a maintenance window or during a low traffic time for the database. Stop the Mongo service, remove all of the MongoDB packages, mongodb.org, and also remove your log files or archive them somewhere if you would rather do that.
So we're starting off by, again, stopping Mongo first. So we're running sudo service MongoDB stop. And then once that completes, the second is a command that's going to look for all the mongodb.org packages and erase them. So we're running sudo yum erase, and then looking for mongodb.org packages. And everything we're doing now would be considered downtime if you're looking at it from a good time to do this or how long it actually takes. So it's pretty quick. And then we're going to remove the log files. Like Barrett said, you can archive them as well. We're trying to keep it simple here, and we're just going to remove them with rm techr. So it's recursively going through and deleting those.
All right. So you'll notice we, removed log files, we removed binaries, but we didn't touch the data. So the data is still on the server. So the next step is to install Percona Server for MongoDB and the related packages. You have to edit your Mongo comp file, and then you start Percona Server for MongoDB. So we're going to be using the same data that the community or enterprise version was accessing. And while this method does have downtime because you're not shuffling data around or anything, it is relatively quick, and you can script it to be even faster than what we're showing today.
So the first command we're running is installing the Percona repository. So it's sudo yum install and then Percona latest releases. We're then going to enable Percona Server for MongoDB version 4.2. And now that it's enabled, we can actually install it. So it's a sudo yum install Percona Server for MongoDB. So Percona tech server tech MongoDB. And it's going to go through and install all the packages. The server is obviously going to take the longest. And you can kind of see everything that's it's actually installing with the package share, which is nice. And like Bert said, after it installs, we are going to go into the MongoDB configuration. This is highly dependent on where your data directory is. So ours is different than what is in the default configuration. So the DB path we're going into VI now is, so it is when we get here, it's varlib mongo. And for this workshop, we're using data/mongo. So we're just going to go ahead and edit that. So it's actually going to use the same database data. And that's pretty easy. It's a single change for our environment. And you can actually now just start Percona Server for MongoDB. And that's what we mean by it's a drop-in replacement. And then the next method is the replica set takeover.
Yep, so this is probably the more common method because by default, MongoDB has high availability and failover built in. So if you're using it, why not take advantage of that? I guess the only reason not to would be cost savings if you don't want to have, 3 VMs or servers spun up. So for our lab, we're starting with a 2-member replica set. Obviously, this is not best practice. Best practice is 3 or an odd number higher than 3. But for the demo purposes, a replica set can function like this. So we're starting with 2 nodes, a primary and a secondary, running MongoDB community. And we're gonna first show this server on the right here. And we're gonna install Percona Server for MongoDB. Make sure our configs are correct to be functioning within the replica set. And then we'll start Percona Server for MongoDB.
So we are installing Percona Server again. So these steps are all going to be the same as what we just did. But before we start it, we're going to make a couple of different changes. And I'll talk to those as we get to them. So we've downloaded the Percona repo. We've enabled Percona Server for MongoDB 4.2, now installing it. So I did mention that we have a specific data structure for this workshop. The next steps after this is actually going to be creating that data structure. So you're going to see a make dir command for data Mongo. And then we're going to change the ownership and permissions to make sure that MongoDB can actually access it. So there we go, everything's downloaded. I'm gonna make our directory and change ownership. And this is where it starts to get, it's the same method, but it's a little different in that we have to add a few more things to our configuration file because we're now working with a replica set. So the first thing we're gonna do is use our data Mongo path to be consistent. Next thing we're gonna do is we're gonna go onto replication because we're now actually utilizing that. So we're gonna uncomment it, and then we're gonna add in a line underneath for the replica set name to be RS0, which is already set up on those other two Mongo nodes that Barrett had shown in the architecture diagram in the previous slide. And then we're gonna go up to the bind IP and add in node 3, because this is going to be the third node. So a couple more changes. Makes sense. So then again, drop in replacement. So you just fire this Percona server up, and it works.
Yep, great. So a few more steps than the other config changes, but mostly just making sure the data is pointing correctly, and then adding replica set config info. Okay, so next steps, we're going to show the status of our running replica set. So in this previous step, our application's been functioning fine. It's using the existing MongoDB community or enterprise version, so we haven't had any downtime. During this step, we're going to add our Percona server node to this cluster, and then we'll recheck the status to show we've gone from a primary and a secondary to a primary and two secondaries. So this is, when we keep saying drop-in replacement, this is what we mean. You can run Percona server with other versions of MongoDB as long as it's like for like versioning.
So we're running two scripts for this one. The first one is going to show the initial status, which is going to be those two nodes. So we're going into our scripts directory. It's RS status. We have a primary and secondary, node 1 and node 2. We're doing RS add. It's not a script. We're just adding this node to the replica set. We're going to rerun the status, and we're going to have three nodes. We see we have node 3, that Percona node, and it's a secondary node right now.
Okay, so now that Percona server for MongoDB is a part of our replica set, kind of the next step is to do a step down from the primary, which used to be, this diagram is kind of showing what we will have after this step is completed, but we were servicing requests from this top MongoDB community enterprise node. We're going to step it down and allow our Percona server for MongoDB node to take over as primary and begin servicing requests. So this would be a part where you might have a little bit of a blip or downtime, but it would be very minimal. You'll see how kind of quickly this can go.
So the first command running is a script. It's just called rs reconfig, and it's adjusting the priority for the Percona node so that when there's an election, it's going to get picked to be primary. And then it initiates an rs.step down. So it hasn't stepped down yet. I waited about 10, 15 seconds and rerun it, and we see that that bottom node 3 is now the primary. And Barrett showed the diagram where you have the Percona as the primary and the Mongo community or enterprise as secondaries. You would actually just do in-place upgrades for those remaining nodes, depending on the size of your environment. And then you could have everything as Percona server.
Yep, so basically on the remaining two nodes, you repeat that in-place upgrade process that we showed as the first step, but because we're running a replica set, there's going to be no downtime. You're just servicing the secondaries. You'll have a moment where you're exposed from like a high availability perspective. You'll have a single kind of failover option should something go wrong, but for the most part, it's zero downtime. So we're going to show in these steps kind of the database functioning. You've successfully completed the migration, and you're able to basically treat this as you would MongoDB Community or Enterprise. Nothing from your app side needs to change, so it just keeps moving along.
So we're going to run our QueryDB script. Initially, it's going to return that same document count, so 29,353. So we're on the Percona node, which is the primary. We want to make sure that that data has replicated to our secondaries as well. So we're going to run another script called query slave, and that's just it's reading off the secondary node to get a document count as well. And we have 29,353. And there's actually a town in Texas called Smiley, Texas. So that's what we're using for this example because it's got a fun name. So we have one document, Smiley, Texas, and that's the population of 972. We're now going to insert another document, which is another entry for Smiley, Texas, which we don't want or wasn't intentional. But we want to make sure that it did replicate. So we have 29,354. So it did go up from 53 to 54. We want to make sure that the exact document is there. So we're running query Smiley again off the replica node, and we see that we have two entries. So we actually want to delete that document. So we have another script, which is just removing that second entry for Smiley, Texas. We're going to run our query Smiley script. We see that we have one entry again for Smiley, Texas. And run it on our secondary. See that again, one entry for the document. And now that we have our replica set up and running, a very common question is, what can you do to monitor it? And what does Percona have? So I think it's valuable to talk about Percona monitoring and management for just a minute, or PMM. So PMM really is designed to be a single pane of glass for your entire database environment, meaning that it's a single tool that has monitoring for all of your open source databases. So out of the box, it works with MySQL, MariaDB, MongoDB, and Postgres. And there's a couple benefits from it. It allows you to optimize database performance, so you can look at query metric information, which can help you easily find and fix and prevent issues when you're trying to scale. Maybe you're hitting some bottlenecks or experiencing outages. It can help improve your data security. We have an integrated security threat tool, and also again using query analytics. And it also helps you to reduce complexity. And just think, again, you have that single pane of glass looking at your entire database environment, and they can be deployed in a couple of different places too. So on-prem, in the cloud, it'll even monitor some DBaaS solutions like RDS.
Yep. So to monitor our replica set, you can use PMM. Here's an example of some graphs which help you to optimize performance. We do have query analytics built in, so you can see the actual queries running within MongoDB. You can organize by total execution time. You can search by fingerprint or by full text string to diagnose issues, either user reported or poking around yourself. These dashboards are available by default out of the box within PMM, so you can use them to diagnose issues, or you can create custom dashboards. We're gathering a lot of metrics from MongoDB, so you can have super high level, just like up-down status of your replica set, which one's primary, which one's secondary, but you can also get really deep into wired tiger metrics, checkpoints, things like that for more advanced users.
And one thing I did want to point out is, we keep saying out of the box it works with those couple different database technologies, but it is built off of Prometheus and Grafana. So if there's a Prometheus exporter for another database technology, another service, you can integrate it into PMM as well. So PMM can help you reduce or ensure data security. So it can do this initially by reducing maybe some possible data exposures. So by using our query analytics tool, which is the screenshot down at the bottom, you can examine all the queries in your database. So you could pretty quickly identify maybe some unexpected queries and determine if they're valid or maybe even malicious. And then you can see who's asking and kind of what data they're trying to get. It can also help you increase database security. So we have a security threat tool, which is those top 2 screenshots. This is going to give you the ability to identify some common database security risks for MySQL, Postgres, Mongo, and Maria. So that's going to help you save time, trying to do some of those things manually and potentially reduce some risk as well. And it can also help you ensure compliance. With the threat tool, you can run regular scans and security checks for your databases. You can get alerts when they don't pass. You can also audit your security check history as well. And then PMM is going to enable you to show that your databases are to date with any details on actually how to remediate those failures for the security threat tool. And PMM can also help you reduce the complexity. So again, you have a single monitoring solution. You can have your DevOps and DBA teams using that same tool for your entire environment. So, again, if you're on-prem, in the cloud, AWS, Google, Azure, all the big ones, it's going to work in there because those are just VMs. Again, MySQL, Postgres, Mongo, Maria out of the box, and then anything that has that Prometheus exporter, you can add into that single pane of glass as well. And also can help you improve your visibility. So Barrett had talked about some of these specific dashboards. There's a ton of different dashboards for these services. You can, really hone down to a specific metric or instance with the tool.
Yep, and because it's open source software that we develop, you are benefiting from our expertise in kind of developing dashboards for MySQL, Mongo, and Postgres. But you can also extend that visibility. So it uses Prometheus as a time series data store. Prometheus has a lot of exporters for other database technologies. So if you have Mongo in-house, there's a chance you have Cassandra or something else that Prometheus will have an exporter for, and you can just kind of extend PMM to give you more visibility into databases that you're managing.
So we've talked a lot about our software and what Percona can do, but we can also do a lot more as well. So we often will partner with companies when you need those database expertise to help optimize your database environment. So there's a couple of different ways we can help you. So you could partner with our professional services to do things like a comprehensive performance review. Maybe you're trying to re-architect and you need help designing it or implementing it as well. That's something we do pretty frequently. Any kind of migration, performance tuning, or anything else that your business would require. We can do that through our professional services or consulting team. We also have training for our database technologies. We also have a 24/7/365 support service. It's, you can cover your entire environment, and there's unlimited usage for support tickets, and you're getting access to a Percona expert off the bat. And we actually can, help you to run or completely run your database for you with our Percona Managed Database Service. This is a pretty flexible engagement model. So you can either have us be your DBA team, or if you have a DBA team in-house but just want some augmentation and help from experts like Percona, we can do that as well.
So some common reasons that you might want to engage our professional services side of the house, specifically on a MongoDB migration effort. We showed pretty basic steps, which you can probably get away with if you're running a single server or you're running simple replica set. But when it comes to a sharded environment, there's a few extra steps to consider with your routers and config servers, as well as hidden secondaries complicate that effort slightly more. If you have a multi-cloud deployment model, you might have to deal with additional complications like latency or how to deploy those across multiple cloud environments. Advanced configurations like weighted balancing of replica set members, things like that. Replacing functionality from Ops Manager, Atlas, or Cloud Manager. We showed PMM to kind of give a sneak peek at that, but it's a little more complicated than that, especially if you're using a lot of enterprise features or a lot of Ops Managers features. We do have some replacements. We didn't really get too in depth into them, but there are, gaps or new ways of doing things that are important to learn and overcome. So those are where I would recommend kind of trying to reach out if any of those may apply to your organization.
So we wanted to give you our LinkedIn information so you can contact us if you have questions about this webinar or want to engage Percona for assistance as well. Our information is there. And then Kim, I don't know if you have any questions from attendees that you want to ask.
I definitely do. So if you guys are all set, we'll start asking those. And I had one that came in about migration. So if migrating from MongoDB Enterprise to Percona binaries, which are more cost effective, can implementations that use LDAP and Kerberos authentication be migrated using replica set takeovers to avoid excessive downtime? It's a lot of words, so let me know if you need me to repeat it for you.
I think I understand. So if you're using enterprise LDAP or Kerberos authentication, can you do the replica set takeover method to migrate to Percona Server?
That's,
yes.
I think, yes. Okay.
Yes, you can. You just have to ensure that those config settings on the Percona Server side are correct. So much like how we were ensuring that our replica set config and data directory for our implementation was correct, we would want to test and make sure that the LDAP functionality on the Percona Server side was working as expected in a test environment with your application before conducting that takeover method.
Okay, and there was a second part of that question. They wanted to know, does the replica set takeover method also work for sharded implementations of MongoDB that use config database replica sets?
So it's part of, go ahead.
Go ahead, Stephen.
You can just piggyback off what I'm saying. So, you would use a similar method. There's some more added steps and complications with sharding. But, that is one of the steps you would take. And Barrett, I don't know if you have any more information about, what steps you would need to take.
Yeah, we can put the steps in our Q&A follow-up, but it's a very similar method to doing just a replica set.
Okay, and so we had another question come in. Does PMM support notification?
So PMM has alerting, so you can configure alerting on any of the metrics that we're monitoring in MongoDB or any of the other database technologies that are in there.
Yeah, to further clarify that, so currently you would need to use Grafana's built-in alerting or Prometheus's built-in alerting. They both have alerting functionality. It just depends on which one you would like to use more. Grafana has the graphical user interface for configuring alerts. It's probably better for smaller environments. If you are a larger environment, you should probably look at Prometheus alerting, which you can configure with like just YAML files, so it's easier to automate from that perspective. It is on our roadmap to provide like a Percona alerting mechanism, which may or may not integrate portions of those, but currently those are the two options with alerting with PMM.
Okay, and then we had a shout out for PMM. One of our attendees said it was great and they're looking forward to trying the new version. So good to know. And then we had one more question. When is the best to migrate from MySQL to MongoDB? Let me start again. When is the best scenario to migrate from MySQL to MongoDB as a replacement? So I guess is MongoDB, when's the best time to go from MySQL to MongoDB as a replacement software?
I think there are a lot of, like I said, I think there are a lot of considerations for that switch. You know, is MongoDB, is that a better fit for your business requirements in your application? And then do you have the time to test that migration, ensure that, you know, everything functionally is still working? Those are just some considerations for it.
Yeah, I think to further elaborate on that, they are kind of, so Oracle and MongoDB Inc. are kind of trying to grab each other's market share. So MongoDB implemented transactions, cross-cluster transactions. I believe they have sharded transactions now too, but that does not necessarily mean that MongoDB is a great transactional data store. Can it do it? Yes, it checks the box, but is it the best solution? Probably not. Same thing on the MySQL Oracle side. So they implemented JSON functionality, so you can store documents in MySQL now. But if you have a use case where it makes sense to have document storage, you probably shouldn't standardize on MySQL. You should choose a document data store, which is optimized to store that kind of data. So from a Percona perspective, it would be right tool for the right job. You should never just like go to MongoDB because it's cool or fast or has built-in high availability or something like that. It would really be like case-by-case recommendation.
Okay, well, that was our final question. So if there's no further coming through, then I'm going to give you guys back about 10 minutes in your day. And thank everyone for joining us. So thank you, Stephen. Thank you, Barrett. Just as a reminder, this is being recorded, so these will go out. I will send the questions over to both Stephen and Barrett for additional follow-up, and we'll put them in a blog later this month along with the recording. So thank you, everyone, and have a great day. Thanks, guys.